let's talk a little bit about marine heat waves, because you often hear about coral bleaching. And coral bleaching is associated with a prolonged heat stress. Okay, it's to do with the temperature of seawater, okay, with the sea temperature. Okay, and the sea temperature is not linked to the air temperature. Okay, there is no direct link. If you have an atmospheric heat wave, does not mean you get an heat wave in the ocean because of the large heat capacity of the ocean. It takes a long time to heat up or cool down. So there are different reasons for marine heat waves. Let's talk about these marine heat waves, shall we? Okay. So what are marine heat waves? There are events of unusually warm water lasting for weeks to months in the surface ocean. Okay. Possible consequences: coral bleaching, development of toxic algae blooms, and potentially the development of dead zones, which are related to the depletion of oxygen levels. Okay. So what are the causes? The causes, or the main cause of heat waves, is the change in the dynamics of warm water currents. Okay, that's a key reason. Okay. You can also create marine heat waves through large air-sea heat flux anomalies associated with cloud cover anomalies, but that's a different story. The main reason is the change of the dynamics of so-called warm water currents. Okay, what are warm water currents? Warm water currents are currents that move water from the subtropics, tropics, subtropics, and move them poleward into cooler climate, like the Gulf Stream. But let's talk about the Australian ones. But first of all, we look at one example. Okay. So let's have a look at how it looks like a warm water current. So here's one example shown here. A warm water current. Temperature is illustrated in terms of colors. The color shading red is for the warm water, flowing southward here along the west coast of a continent. That's an example of the Lewin current moving southward along the west coast of Australia. So now assume that this current in 1 year is intensified, it's much stronger. So what it does, it actually moves warmer water further southward. Okay, and if you look at the difference, you can see that it's cold in 1 year, warm in another year. Okay, and that's an intensification of the current. And I'm not talking about the reasons, which might be changes in the wind forcing of these currents. Anyway, just showing you the key change. Key change is moving warmer water further southward. What these currents also can do, they can actually move organisms that come from subtropical, tropical regions further southward just by the movement, okay? Displacing marine organisms which are contained within the current further southward, which can cause pests and infestations. Okay, show you two examples. One is the 2011 marine heat wave caused by intensification of the Lewin current. And there's a map shown on the left, and it shows you the temperature anomaly compared to normal conditions. You can see an area which is much warmer. Okay, and we're looking at temperature anomalies of 2 degrees. It's shown here in this sketch. 2 degrees up to 2.5 degrees warmer. Okay, and this is what we call a marine heat wave. Okay, and it shows you a time series. Okay, a time series. This is in terms of week numbers. Starts at the beginning of the year and then goes to the end of the year. week numbers, and it shows you the average of the years 2006 to 2010. It's the blue dots here, and the red dots is the year 2011. And you can see it's much warmer. It starts much warmer and becomes much warmer. Okay? And that's to do to the intensification of this Lewin current. Okay? All right. So that's one example. Okay, and this is where the hot spots are. This is where you get the marine heat waves. Okay? I'll show you another example, which is on the east coast of Australia. Marine heat waves of along Australia's east coast, which are linked to coral bleaching. If the heat wave occurs in the area of the Great Barrier Reef. Okay, here's one example, 1998, and again shows you temperature anomalies above long-term climatological mean. Okay, and you can see much warmer, almost 4 degrees warmer, reaching 5 degrees warmer in this area here, which is to do with the intensification of the East Australian current, which is also a warm water current that comes here from the north. If you make it stronger, it extends further to the south, and you can see it actually creates a large range. This is actually something we call the Tasman front, a large zone of warmer water. And this is the effect of this intensification of the current. In contrast, 2002, you see one example where you have also a marine heat wave, but not so pronounced in 2002, but more located over the Great Barrier Reef in this area. And this heat wave is actually more triggered by air-sea heat flux anomalies over a longer time. Okay, so this is examples of marine heat waves. Okay, and they work differently to atmospheric heat waves. So some study questions. What are extreme events? Which statistical methods are used to analyze extreme events? What are hydrological extreme events? What type of extreme climate indices are used to analyze atmospheric data? What are marine heat wave? Okay, thanks for watching.